Now, in this lecture, we will find the area of the green triangle. In the drawing, we have triangle ABC that is an equilateral triangle, and we know that BD equals to 2 units, DC equals to 4 units, and AF equals to BF. And we want to find out the area of the green triangle. So, first of all, we know that the angles in any equilateral triangle is 60 degrees, so all the angles here is equals to 60 degrees, and the sides of equilateral triangle are equal to each other, so actually BC equals to BD plus DC, and BD equals to 2 units and DC equals to 4 units, so actually BC equals to 6 units, so all the sides of the equilateral triangle ABC equals to 6 units. So we actually can write down that AB equals to BC equals to AC equals to 6 units, because it is 2 plus 3, the size of BC is 2 plus 4 is 6 units, so the size of BC is 6 units, and all the sides of equilateral triangle are equal to each other. So actually AB equals to BC equals to AC equals to 6 units. So actually AB equals to 6 units, and we know that AF equals to BF. So if we define AF as X, then BF also will be defined as X. So actually we know that X plus X equals to AB, or 2X equals to AB. Okay, 2X equals to AB, that is the size of AB is 2X, because it is BF plus AF, and AF is X and BF is X, so AB equals to X plus X, that is 2X. But we know that AB equals to 6 units, so we can write here that AB equals to 6 units. We'll divide this equality by 6, and we will get that X equals to 3 units. So actually we found out that the value of the size of AF is 3 units, and the size of BF is also 3 units. Okay, in the next step we will define FD as A, FD equals to A, and DE equals to B, and we will use the law of cosines in triangle BFD. Okay, in triangle BFD we will use the law of cosines. Actually the law of cosines is if you have triangle ABC Okay, so in this triangle, we know that the sides of this triangle and this angle is angle theta. According to the law of cosines, c square equals to a square plus b square minus 2 times ab cosine of cosinus of theta. Okay, so according to the law of cosines, c square equals to a square plus b square minus 2 times ab cosine of theta. Okay, here we will subtract c square from this equality and we will add to this equality 2 times ab cosinus theta, and we will get that a square plus b square minus c square equals to 2 times ab cosinus theta okay. We subtracted c square from this equality and we add to this equality 2 times ab cosinus theta, and we got that a square plus b square minus c square equals to 2 times ab cosinus theta. Now we will divide this equality by 2 times ab and we will get that cosinus theta equals to a square plus b square minus c square over 2 times ab. Okay, so we actually derived this equality that cosinus theta equals to a square plus b square minus c square over 2 times ab from the law of cosines, and we actually can implement the law of cosines in our drawing, because here we can write down that cosinus 60 degrees according to this equality, cosinus 60 degrees equals to bd square plus bf square minus 2 times bf times bd minus c square. C square is fd square over 2 times AB. 2 times AB is 2 times BD times BF. Okay, in total we got that we implemented this equality in triangle PFD, and we got that cosinus 60 degrees equals to BD square plus BF square plus FD square over 2 times BD times BF. Okay, so cosinus of 60 is half 1 over 2. Cosinus 60 is 1 over 2. So 1 over 2 equals to BD square. BD equals to 2. So 2 square is 4 plus BF square. BF equals to 3 units. So 3 square is 9 minus FD square. FD is defined as A, so FD square is minus A square over 2 times BD times BF. 2 times BD is 2 and BF is 3. So in total we got that half equals to 4 plus 9 minus A square over 2 times 2 times 3. So here we can cancel 2 because we have 2 in the denominator of this side of the equation, and we have 2 in the denominator of the other side of the equation, so 2 is cancelled, and in total we will get that 1 equals to 13 minus A squared over 6. Okay, 4 plus 9 is 13, and 2 times 3 is 6. Now we will multiply this equality by 6. We will get that 6 equals to 13 minus A square. Okay, we got that 6 equals to 13 minus A square. Now we will add A square to this equality and we will subtract 6. We will get that A square equals to 7. Okay, we added A square to this equality and we subtracted 6. We got that A square equals to 7. We will take a root out. We will take root out of this equality. We will get that the value of A is root of 7. Okay, so we actually got that the value of A is the root of 7, so we can write here that A equals to the root of 7 units. Okay, now in the next step we will define angle BFD as theta. Angle BFD equals to theta, and we will define angle BDF as alpha, and we will also define angle DEC as beta, and angle CDE will be defined as gamma. Okay, we know that the sum of the angles in any triangle is equal to 180 degrees, and in triangle BFD it is also true that the sum of its three angles equals to 180 degrees, so we will write it down in triangle BFD. the sum of its angles equals to 180 degrees. That is to say, equation number 1 will be that 60 degrees plus theta plus alpha equals to 180 degrees. Okay, the sum of the angles in triangle BFD is equal to 180 degrees, and the same thing is true in triangle DEC. The sum of its angles equals to 180 degrees. So equation number 1 will be that gamma plus beta plus or 60 degrees plus gamma plus beta equals to 180 degrees. 60 degrees plus beta plus gamma equals to 180 degrees, because of the fact that the sum of the angles in any triangle in the world equals to 180 degrees, and especially in triangle DEC, the sum of its angles is 180 degrees. Okay, so we got that 60 degrees plus beta plus gamma equals to 180 degrees. So we have here two equations. In the next step we will add equation number 1 to equation number 2. We'll get equation number 3 that states that 60 degrees plus 60 degrees is 180 degrees, plus theta plus alpha plus beta plus gamma. 180 degrees plus 180 degrees is 360 degrees. Okay, so we added equation number 1 to equation number 2, and we got that 100 degrees plus theta plus alpha plus beta plus gamma equals to 360 degrees. We will subtract 100 degrees from equation number 3. We'll get that theta plus alpha plus beta plus gamma equals to 240 degrees. Okay, after we subtracted 180 degrees from equation number 3, we got that alpha plus theta plus alpha plus beta plus gamma equals to 140 degrees. As you have already know, the sum of the angles in any straight line equals to 180 degrees. Actually, the sum of the angles on the upper side of any straight line equals to 180 degrees, and the same thing is true that the sum of the angles in the down side of any straight line equals to 180 degrees. So here the sum of the angles around point D in the upper side of line BC, that is a straight line, equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees, because of the fact that the sum of the angles in a straight line, in the upper side of a straight line, equals to 180 degrees, and the same thing is true to say that the sum of the angles in the lower side of any straight line equals to 180 degrees. So we will have equation number 4 that states that the sum of the angles in the upper side of a straight line equals to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. Here we will subtract 90 degrees from the fourth equation. We will get that alpha plus gamma equals to 90 degrees. Okay, we got that alpha plus gamma in the fourth equation, that alpha plus gamma equals to 90 degrees. Okay, so actually we can subtract, or we can substitute alpha plus gamma in the third equation, but we can substitute alpha plus gamma in the third equation by 90 degrees, because alpha plus gamma equals to 90 degrees. Okay, here we can subtract alpha plus gamma by 90 degrees, because alpha plus gamma equals to 90 degrees. So in the third equation we will get that theta plus beta plus 90 degrees equals to 240 degrees. So actually in the third equation substituted alpha plus gamma by 90 degrees. Because of the fact that alpha plus gamma equals to 90 degrees, we got that theta plus beta plus 90 degrees equals to 240 degrees. Now we will subtract 90 degrees from equation number 3. We will get that so we got that theta plus beta equals to 150 degrees. We'll subtract theta from equation number 3. We will get that beta equals to 150 degrees minus theta. Okay, we got that beta equals to 150 degrees minus theta. Okay. In the next step, we will use the law of sines in order to find out the value of sinus theta. According to the law of sines, if we have a triangle according to the law of sines, in any triangle if we have a triangle with sides A, B, and C, and angles alpha, beta, and gamma, according to the law of sines, the following relationship exists between the sides of the triangles and the angles of these triangles. According to the law of sines, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, it is true for any triangle in the world. This relationship exists between the angles to the sides of any triangle. A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, that is the law of sines. Okay, so we actually can implement the law of sines in our triangle in order to find out the value of sinus theta. According to the law of sines, BD over sinus theta, BD over sinus theta equals to FD over sinus 60 degrees. Okay, so we actually implemented the law of sines in triangle BFD. Okay, in triangle BFD, according to the law of sines, BD over sinus theta, BD over sinus theta equals to FD over sinus 60 degrees. Okay, but we know that sinus 60 degrees equals to root 3 over 2, and FD equals to root 7. So in total we will get root 7 over root 3 over 2 equals to BD equals to 2 units, and sinus theta is the missing variable. Okay, so in total we got that 2 over sinus theta equals to root 7 over 1 over root 3 over 2. Okay, so here we can actually do the simple arithmetic. We'll get the 2 times root 7 over root 3 equals to 2 over sinus theta. Okay, so actually sinus theta will be equal okay, we'll get from this simple equality that sinus theta equals to root 3 times 2 over 2 times root 3. Here we have 2 in the numerator and in the denominator, so we can cancel 2. So in total we got that the value of sinus theta is actually root 3 over 7. Okay. Okay, the value of sinus theta is actually root 3 over root 7. Root 3 over root of 3 over 7. Okay, and now we will get the value of cosinus theta according to the trigonometric identity that the sinus theta squared plus cosinus theta squared equals to 1. Okay, we have this trigonometric identity that states that sinus theta squared plus cosinus theta squared equals to 1. Now we will subtract sinus theta squared from this equality and we will take a root of this equality. We will get that the value of cosinus theta equals to 1 minus sinus theta squared, the root of 1 minus theta squared. Okay, the value of cosinus theta equals to the root of 1 minus sinus theta squared. But we know that sinus theta equals to the root of 3 over 7, so sinus theta squared will be equal to 3 over 7. Okay, sinus theta squared. If sinus theta equals to the root of 3 over 7, then sinus theta squared will be equal to 3 over 7. Okay, sinus theta squared equals to 3 over 7 units. So we will put this data inside this equality. We will get that cosinus theta equals to the root of 1 minus 3 over 7. 1 minus 3 over 7 is 4 over 7. So in total we got that the value of cosinus theta equals to the root of 4 over 7. Okay, cosinus theta equals to the root of 4 over 7. The root of 4 is 2, so we can write it okay, so we actually got that cosinus theta equals to 2 over root 7, while sinus theta equals to the root of 3 over 7. Okay, or we can write here that sinus theta equals to the root of 3 over root 7. Okay, so we know that sinus theta equals to the root of 3 over root 7, while cosinus theta equals to 2 over root 7. Okay, but as you might remember, we have already found out that beta equals to 150 degrees minus theta. We've already got that beta equals to 150 degrees minus theta. I can show you that we found it we found here that beta equals to 150 degrees minus theta. Okay? In the beginning of the lecture, we found out that the value of beta is 150 degrees minus theta. Okay? So, actually, if beta equals to 150 degrees minus theta, beta equals to 150 degrees minus theta, then sinus beta will be equal to sinus 150 degrees minus theta. Okay? Beta equals to 150 degrees minus theta, so sinus beta equals to sinus 150 degrees minus theta. Okay? Very simple. But we know that according to the trigonometric identity, the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Actually, we have trigonometric identity that states that the value of sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, so we can calculate the value of sinus beta or sinus 150 degrees minus theta according to this trigonometric identity. When alpha equals to 150 degrees and beta equals to theta. So we can write down that the value of sinus 150 degrees minus theta equals to sinus 150 degrees times cosinus theta. You should remember that we have already found the value of cosinus theta, minus sinus beta. Sinus beta is sinus theta, cosinus alpha. Cosinus alpha is cosinus 150 degrees. So we actually have all the values of all the variables here. First of all, we know that sinus 150 degrees equals to 1 over 2. And cosinus theta, we have already found out that the value of cosinus theta is 2 over root 7. Okay, so minus sinus theta, we have already found out that the value of sinus theta is root 3 over root 7, all multiplied by cosinus 150 degrees. Cosinus 150 degrees equals to minus root 3 over 2. Okay, minus root 3 over 2. So actually in total we got that sinus beta equals to 1 over 2 times 2 over root 7. So 2, we have 2 in the numerator and 2 in the denominator, so 2 is cancelled, minus root 3 over root 7 times root 3 over 2. Minus times minus is plus, and root 3 times root 3 is 3. So we'll write it down. So in total we got that sinus beta equals to 1 over root 7 plus 3 over 2 times root 7. We can take a common factor of 1 over root 7 from this equality, and we will get that 1 over root 7 equals to, here is 1. We took 1 over root 7, a common factor of in this equality, and we'll get it is equals to 1 plus 3 over 2. Okay, so in total we got that sinus beta equals to 1 over root 7 times 1 plus 3 over 2. 1 plus 3 over 2 is 2 half, or 5 over 2. So it equals to 1 over root 7 times 5 over 2. Okay, in total we got that sinus beta equals to 5 over root 7 times 2. Okay, so I write it down. The sinus beta equals to 5 over 2 times root 7 okay, sinus beta equals to 5 over 2 times root 7. Okay, so in the next step we'll focus on triangle DEC. Actually, we will implement the law of sines in triangle DEC. In triangle DEC, we can say that b over sinus, according to the law of sines, b over sinus 60 degrees equals to dc over sinus beta. You should remember that we know the value of sinus beta. We have already found that sinus beta equals to 5 over 2 times root 7. And we already know the value of dc. It is given us in the question. So it equals to dc over sinus beta. Okay, as you can see from this implementation of the law of cosinus, law of sinus in triangle DEC, the only missing variable is here is b. So we can put the data, we will put the data inside this equality. We will get actually that b over sinus 60 is sinus 60 degrees is actually root 3 over 2 all equals to dc. dc equals to 4 units, and sinus beta equals to 5 over 2 times root 7. Okay, in total we got that b over 1 over root 3 over 2 equals to 4 over 1 over 5 over 2 times root 7. We'll do the simple arithmetic here, and we will get that 2 times b over root 3 equals to here. So in total we got that 2 times b over root 3 equals to 4 times 2 over root 7 over 5. Okay, so we'll do here the simple arithmetic. Here we can cancel 2 because we have 2 in the numerator of this side of the equation, and we have 2 in the numerator of this side of the equation. So we can cancel 2, and we'll get that b equals to 4 times root 7 over root 3 over 5. Okay, we got that b equals to 4 times root 7 times root 3 over 5. Okay, but we know that the area of any triangle equals to the base of the triangle times the height, and the height must create 90 degrees with the base. So the area of the green triangle will be equal to a times b over 2. Okay, a times b over 2. A times b over 2 is the area of the green triangle, because it is the base is b, the height is a, so we multiply a times b over 2 is the area of the green triangle. But we know that a equals to the root of 7, while b equals to the root of 7 times 4 times the root of 3 over 5, and all we divide by 2. Okay, so the area of the triangle equals to the root of 7 times root of 7. So root of 7 times root of 7 is 7, and 4 over 2 is 2. So we can write here that the area of the green triangle equals to 7 times root 3, 4 over 2 is 2, all divided by 5. So the area of the triangle will be equal to 3 times 7 times root 3 times 2 times 5. But 7 times 2 is 14, so I write it down. So actually we got that the area of this green triangle equals to 14 times root 3 over 5 square units, and we can say that the area in terms of numbers equals to equals to 4.85 units, square units. The area of the triangle equals to 4.85 square units. Okay, the area of this green triangle equals to 4.85 square units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the area of this green triangle, and we have an equilateral triangle. We know that all the sides on equilateral triangle are equal to each other, and all the angles equals to 60 degrees. So we actually can write immediately that the angles, those angles equals to 60 degrees, and AC equals to BC equals to AB, and we also know that BD is 2 units and DC is 4 units, and that AF equals to BF. And we want to find out the value of the area of the green triangle. Okay, actually the size of the side of the equilateral triangle equals to BD plus DC, but BD equals to 2 units and DC equals to 4 units, so BC equals to 6 units. So AC equals to BC equals to AB, because all the sides of equilateral triangle equal to each other. So all the sides of this triangle ABC equals to 6 units. Okay, and we also know that AF equals to BF. Okay, we know that AB equals to 6 units and AF equals to BF. So if AF is defined as X, AF equals to X, BF also will be equal to X. Okay, so AB equals to X plus X because it's AF plus BF. So AB equals to 2X, and we know that AB equals to 6 units. So 2X equals to 6 units, so X equals to 3 units. AF equals to 3 units and BF also equals to 3 units. Okay, so we found out that BF equals to 3 units and AF equals to 3 units. Okay, in the next step we implemented the law of cosines in triangle BFD. Okay, in order to find the value of FD, we implemented the law of cosines in triangle BFD. What is the law of cosines? In any triangle, if a triangle have sides A, B and C and angle theta, according to the law of cosines, C square equals to A square plus B square minus 2 times AB cosinus theta. It is true for any triangle in the world. That is the law of cosines. And we actually can implement the law of cosines. So actually we can derive from this equality that cosinus theta equals to A square plus B square minus C square over 2 times AB. Very simple arithmetic. We can derive that cosinus theta equals to A square plus B square minus C square over 2 times AB. And we will use this equality in order to find out the value of FD, because we can implement this equality in triangle BFD. We can say that cosinus 60 degrees equals to BD square plus BF square minus FD square according to this equation, according to this formula. Okay, so actually cosinus theta equals to BD square plus BF square minus FD square over 2 times BD times BF. Okay, according to this equality, this is the value of cosinus 60 degrees. Okay, and we put the data inside this equality, and we know that the BF equals to 3 units, BD equals to 2 units, and we calculated the value of cosinus 60 is half, is 1 over 2. So the only missing variable here is FD. So it is one equation with one variable, it is FD. We solved this very simple equation, and we found out that the value of FD that is defined as A, FD equals to A equals to the root of 7, according to the equation that we solved. According to this equation that we solved, we found out that the value of FD that is A equals to the root of 7 units. Okay? And then we know that the sum of the angles in any triangle is 180 degrees, and especially in triangle BFD, the sum of its angles is 180 degrees. That is to say, alpha plus theta plus 60 degrees equals to 180 degrees. So that is the first equation, and also it is true that the sum of the angles in triangle DEC equals to 180 degrees. That is to say, 60 plus beta plus gamma equals to 180 degrees. And that is the second equation. And we actually added equation number 1 to equation number 2. And we got the third equation. And then we have the rule that the sum of the angles in the upper side of any straight line equals to 180 degrees. So around point D, if we calculate the sum of the angles in the upper side of the straight line BC, it will be equal to 180 degrees. That is to say, alpha plus 90 degrees plus gamma equals to 180 degrees. And that is actually our fourth equation that states that the sum of the angles around point D in the upper side of the straight line BC equals to 180 degrees. Okay, that is the fourth equation. And actually we derived from equation number 3 and equation number 4 that beta equals to 150 degrees minus theta. Okay, and then we have the law of cosines. In any triangle, A over sinus alpha equals to B over sinus beta equals to C over sinus gamma. Okay, and we implemented the law of cosines in triangle BFO in order to find out the value of sinus theta. We can say that BD over sinus theta equals to FD over sinus 60. We know that value of FD it equals to A that equals to root 7. We know the value of sinus 60, and we know the value of BD, and the only missing variable is sinus theta. So we found out that the value of sinus theta is actually root 3 over root 7. Okay, we implemented the rule, the law of sines in this triangle BFD, and we found out that sinus theta equals to the root of 3 over root of 7. Okay, we can derive the value of cosinus theta from sinus theta because we have the trigonometric equality that states that sinus theta squared plus cosinus theta squared equals to 1. And with a simple arithmetic we can find that the value of cosinus theta equals to the root of 1 minus sinus theta squared. If sinus theta equals to the root of 3 over 7, then sinus theta squared equals to 3 over 7. So we put this data inside this equality, and we found out that the value of cosinus theta equals to 2 over root 7. Okay, so we have the value of sinus theta and the value of cosinus theta. And we also know, we've already found out that beta equals to 150 degrees minus theta. So if beta equals to 150 degrees minus theta, then sinus beta equals to sinus 150 degrees minus theta, because beta equals to 150 degrees minus theta. Okay? And we have the trigonometric identity that states that sinus alpha minus beta equals to sinus alpha cosinus beta minus sinus beta cosinus alpha. Okay, so we can implement this trigonometric identity in order to calculate the value of sinus beta that equals to sinus 150 degrees minus theta. You should remember that we have already found out the value of sinus theta and the value of cosinus theta. The value of sinus theta equals to the root of 3 over root 7, and the value of cosinus theta equals to 2 over root 7. Okay, so we implemented the trigonometric identity in order to find out the value of sinus 150 degrees minus theta, and we found out that sinus 150 degrees minus theta equals to sinus 150 degrees minus cosinus theta minus sinus theta times cosinus 150 degrees. So we know the value of sinus theta and cosinus theta, so we can put it inside this equality, and we found out that sinus beta that equals to this equation is equals to 5 over 2 times root 7 units. Okay, this is the value of sinus beta according to the equality that we have here, and we calculated the value of sinus minus minus 50 degrees minus theta according to the trigonometric identity of sinus alpha minus beta that equals to sinus alpha times cosinus beta minus sinus beta times cosinus alpha. Okay, and we found out that the value of sinus beta is actually 5 over 2 times root 7. Okay, so actually when we know that the value of sinus beta is 5 over 2 times root 7, we can easily find out the value of b, because we can implement the law of sines in triangle DEC. According to the law of sines in triangle DEC, b over sinus 60 equals to dc over sinus beta, and we know, we have already found that sinus beta equals to 5 over 2 times root 7. So in this implementation of the law of sines in triangle DEC, the only missing variable is b, because we know that dc equals to 4 units, sinus beta equals to 5 over 2 times root 7 units, and we can calculate the value of sinus 60. So the only missing variable is b. Okay, we put the data inside this equality, and we found out that the value of b is actually 4 times root 7 times root 3 over 5 units, and we have already found out that the value of a is root 7. So the area of the green triangle equals to the base of the triangle times the height of the triangle over 2. We know that b equals to 4 times root 7 times root 3 over 5 units, and a equals to root 7, so the area of the green triangle equals to b times a over 2, that is the area of any triangle. the base times the height over 2, and the height is A, the base is B, and we know the value of A and B, so the area of the triangle equals to 15 times root 3 over 5 square units, or in terms of numbers, the area of the green triangle equals to 4.85 square units. Okay, the area of the green triangle equals to 4.85 square units. Okay, thank you very much.